In this video, we are going to go over how to translate a word problem into an algebraic expression. It's going to end up being an equation in this case that we can then evaluate. Let's do it. So it says, and by the way, it took me probably longer to write this out on the board than it will to actually do the problem. Side note there. All right, here we go. The distance an object travels at a constant speed is the product of the object's speed and the time it travels. Now, when I read word problems, I translate as soon as I can, and I can now translate something. We've got the distance, I'm going to call that d, that an object travels at a constant speed is the product of the object's speed. Now that's often written as rate. So R for rate. You could also do S for speed, but I'm gonna do R for speed. And the time, T, it travels. So let's think about that. The distance an object travels is, that's equals. So hidden in there is an equation. The distance is equals the product. So that would be the multiplication of the speed, which we're calling R, and the time, which we're calling t. Distance equals rate times time. You've seen that before in earlier math classes, and if not, whoa, we gotta backtrack and check that out, right? Okay, so check out earlier videos on distance equals rate times time then. So now we've translated everything to this period. Let's keep going. Write an expression to represent the total distance an object travels. Oh, we did that. Sweet. So we'll keep reading, knowing that we already did that part. And evaluate, plug in, the expression for a speed of 20. So we're now plugging in numbers. So we're plugging in for 20, that's the speed. Meters per second is the units, or are the units, and a time of 3.7. That's in for t. That's it. We've done everything. So even though the word problem is really lengthy looking, if we read it and translate as we go, we don't have to then translate with everything in our head. It takes the difficulty of the problem and kind of, I don't know, I think it makes it a little bit easier. So now we're just going to simplify this. Now remember, we still have d. So d is equal to 20 times 3.7, a little bit of mental math. I believe that's going to be 74. So d is equal to 74. And we know that the units, since it's distance that we're finding and it's meters per second, it's going to be in meters if you really want to have correct units. So point of this, guys, translate as you read. You'll get an expression, and then it's really just the same as doing an evaluation problem like earlier shown in this lesson.